Alright guys, so we're looking over the 5 questions from today's Regents review. During physical education class, Andrew recorded the exercise times in minutes and heart rates in beats per minute of his 4 classmates. Which table best represents a linear model of exercise time and heart rate? So over here, we're looking for something, if it's linear, that is a constant rate of change. So if you guys remember, that formula is y2 minus y1 over x2 minus x1. That's your slope formula, but also you find constant rate of change. And if you didn't remember it, all you're doing is looking for a table that is changing the same amount each time. So over here, our y2, our x2 is 1, and our x1 is 0, and our y2 is 65, and our x2 is 60. So that's 65 minus 60 over 1 minus 0. That rate of change is 5. So this is changing by 5. Is it always changing by 5? It goes from 60 to 65, 65 to 70, that's plus 5. 75 to 70 to 75, that's plus 5. 75 to 80, that's plus 5. And these are all increasing by 1. Plus 1, plus 1. So the rate of change is 5 over 1. Now this is linear, but let's double check that nothing else is making that same pattern, or we'll just check our other answers. This here is going up from 58 to 65. That is plus 7. And then this one goes from 65 to 70, that's plus 5. We already see it's not increasing by the same amount, so this cannot be the answer. 62 is going up by 8 to 70. 70 to 83 is plus 13. As 83 to 88 is plus 5. This one already isn't linear. And the last one, we have 62 to 65, that's plus 3. We have 65 to 66, that's plus 1. This already is not linear. So our option is 1. Number 2. The functions f of x and g of x are graphed below on the set of axes. Below. For which of value of x is f of x not equal to g of x? So if I take a look at these graphs, it looks like our straight line over here is our g of x, and our curved line that's going up, then down, is f of x. And they want to know which value are they not equal. So let's see, the first option is -1. What we're going to do is we're going to go to -1 on the x-axis, and we're going to scroll up and down. We're going to scroll up and down right here to see if they're ever on the same point. If I go to -1 and I go up a few, they're on the same point right there. They're both equal. So right here, they're both equal. It's not option 1. Let's go to option 2. When x is 2, so we're going to go to 2, 1, 2. And if I look up and down, I see that right at 2, they're both equal here. 2 is not an option. Let's go to 3. Going to 3. 1, 2, 3 on the x-axis. I'm going to look up. I'm going to look down. And they never are on the same point. 3 is our answer, but let's just double check. Let's look at -2. When I'm at -2, 1, -2 is right here. I see if I go up, 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 right here, they're both on the same point. So our option is 3. Going to number 3. A child is playing outside. The graph below shows the child's distance, d of t, in yards from home over a period of time, t in seconds. Which interval represents the child's constantly moving closer to the home? So if I look at my x-axis, I notice our x is time. If I look at our y-axis, I know the y-axis is distance. So when we are at 0 seconds, the child is 10 yards away from home. When we're at 1 second, he or she is about 7. When we're at 2 seconds, they're about 4 yards away from home. So we notice that from 10 to 2, they're getting closer to home. Not 10 to 2, from 0 seconds to 2 seconds, they're getting closer to home. So which ones of these is going to be from 0 to 2? Option 1 is saying from 0 seconds to 2 seconds, the child is going closer to home. To just look at the other options, from 3 to 4, he goes further away from home and then comes back to home. From 3 seconds, he's at 4 feet, and from 4 seconds, he's at 8 feet. They're going further away, and then from 4 seconds to 6 seconds, they're exactly 8 feet away. So our option is 0 seconds to 2 seconds. And our last one. This one was a little tricky, and you had to know how to get formula, but we'll talk about it. The length, width, and height of a rectangular box are represented by 2x, 3x plus 1, and 5x minus 6, respectively. When the volume is expressed as a polynomial in standard form, what is the coefficient of the second term? So they want us to find the coefficient of the second term, but we have to put all of this in standard form. There's one thing I wanted to go back and look at. They said the volume. So before doing this, you had to know what volume, or the formula for volume is. And if you know the reference sheet, the formula for volume is on the reference sheet. So volume is equal to length times width times height. So we don't know which one is which, but they're all multiplying together, so the order really doesn't matter. So we have 2x times 3x plus 1 times 5x minus 6. And we're just going to multiply out to get this into standard form. So 2x times 3x, that becomes 6x squared. 2x times 1, it's a positive, so plus 2x. Now I'm going to put these in parentheses and bring down our 5x minus 6. Now we're going to do double distribution and multiply again. We have 6x squared times 5x. 6x squared times 5x is 30x to the second power. We're going to continue our double distribution to 6x squared minus 6 times negative 6, my bad. And that becomes negative 36x squared. Oh, I had a typo, and no one told me. This 6x squared times 5x is 30x to the third power. 6x to the second power times negative 6 is negative 36x squared. 2x times 5x is positive 10x squared. And 2x times negative 6 is negative 12x. Now, right before we're in standard form, we have to simplify by combining like terms. I notice that we have negative 36x squared and 10x squared are both like terms. So when we combine them, we will have 30x to the third power minus 26x squared minus 12x. Now remember, it's in standard form if all the degrees are going from highest to lowest. We have 30x to the degree of 3, so that's the highest, negative 26x to the degree of 2, and negative 12x to the degree of 1. We don't see it, but we know it's a degree of 1. And the question says, when expressed in standard form, what is the coefficient of the second term? So this here is our first term, this is our second term, and this is our third term. Our answer is negative 26. Now moving on to the last question. This was a short response question. Explain how to determine the zeros of f of x equals x plus 3 times x minus 1 times x minus 8. Now this one isn't a quadratic because we have 3 x values, or x terms. But if we have to find the zeros, we want to use the zero product property. So we're going to use, we will set the equation equal to 0 and use the zero product property to find the zeros. Now let's put that plan into action. We have f of x equals x plus 3 times x minus 1 times x minus 8. Now to state the zeros, we have to find the value of x when the whole equation is equal to 0. So what I'm going to do is I'm going to erase this f of x equals 0. I'm going to make it equal, and then we're going to make the whole function equal to 0. But you know, I'm so used to 0 on the other side, I'm actually just going to move it. So I'm going to erase all of this, and then I'm going to put equals to 0 on the other side. It's the same equation, I just put it on the other side. Now, we're saying that if we multiply all 3 of these together, then at least one of them must be 0 in order for this whole thing to be 0. So we're just going to say x plus 3 equals 0. We're going to also say x minus 1 equals 0. And we're also going to say x minus 8 equals 0. And all we have to do is solve for 0. X minus 3, sorry, we're going to subtract 3 to both sides. X equals negative 3. For the other one, we're going to add 1 to both sides. X equals positive 1. And for the last one, we're going to add 8 to both sides. We're going to do the inverse operation. X equals 8. So the zeros are, I'll type this one. The zeros of the function are negative 3, 1, and 8. And those are your solutions.